Hi, my name's John Harrington and I'm going to take you through the rationale as to why I developed Nodlin. Now let's start with a question. How much time in a day do you spend doing the job that you were employed to do, given your expertise? Now numerous studies have shown that it's roughly between a third and a half of your time. And about 25% of the time is spent, if you're a knowledge worker, collating information to help you do your job. So information and communication management is a huge issue in terms of efficiency. And numerous tools have been developed to handle both structured and unstructured communication. But I believe that there's a fundamental issue with these, and that's what Nodlin was developed to address. So what do I mean by unstructured and structured communication tools? Well, I've put them into two buckets. The unstructured communication tools are like the catch-all, like email and chat. All of the document type tools like Word, Excel, PowerPoint, Visio, and Lucid Charts. They're very flexible. You can represent lots of different information using those tools, but they are a snapshot. They're a snapshot at a point in time. They're true when you create them. Now you may have a process where you go and update those. You might update it, say, once a month if it's a status report, and then send that status report to different people. But they're a snapshot. The other types of tool are the structured tools. They're things like Jira, Asana, Monday, Whimsical, etc. Now those tools work on a schema, well-defined information, and as long as people do their updates, that's the place to go to get that information. The problem is, though, that organisations are networks of systems and people, and all information is connected in some way. Now, a lot of tools provide connectors where you make a change and it will apply the change in another system. That implies that the other system is eventually consistent with yours. Now, in other cases, you have import-export, a batch process that might update alternate systems on a nightly basis. You might cut and paste. You might even rekey or not update it at all. There's always risks there. But essentially, these systems are islands of consistency, where the problem is really where you want consistency across all the data flows. Now, I don't believe we need more tools when considering the issue of managing this consistency. New tools add a license cost, and an install cost, and a maintenance cost, and a user training cost, and so on. What we need is a platform that enables us to add the features that are required that tools would provide, but being able to help us maintain that consistency. So I have spent over 20 years of my career working for two large IT organisations, managing multiple teams across regions. So I've seen a lot of communication issues. Now, one of the principles that developers apply when they're coding and in order to improve their efficiency is to apply the drive principle, which is do not repeat yourself. So they'll write scripts so that they can execute the steps quicker next time. Now, when you're managing teams, there's a lot of follow-up, status, email, chat communications, etc., in order to keep up to date with information. And you are translating that information to support the different perspectives of the people elsewhere in the organisation who care about what's going on. So apart from the expertise you bring to the job, from knowing the domain, there's a lot of work and time spent in translating and communicating that detail that's been given. And all this introduces a lag in transparency and a higher cost in having to manually translate and communicate this information. So the question is, can we have a single platform that provides the ability to have a more structured approach to communication? And for all those data points to be reactive to other data points that we generally see across different tooling. And the other question is whether this platform can be additive, i.e. we can add features to the platform without having to purchase new tooling, and for it to be flexible enough so that you can quickly tailor and configure the tool so that it can support your organisational communication patterns. So this is where Nodlin's reactive graph technology fits in. So rather than installing a tool that maintains the consistency of all of the data points it manages, say, for example, you have a tool that looks after a requirement and a task, rather than having a combined logic that maintains the consistency of those two elements, with Nodlin, you introduce an agent that exposes its ability to manage a requirement and a task separately. So obviously the requirement can understand the task and vice versa, but their logics must be able to work independently, like nodes in a graph. So the advantage of that is you can introduce tools which expose their capabilities, and the user can connect those capabilities to capabilities that are provided by other agents, and typically by what we know now as the other tools. So this enables Nodlin to provide the base framework for managing that propagation of change. Now, I don't have a lot of time to go through all the different features that Nodlin supports, but I'll go through a few examples to highlight the key UX features which are key for searching and finding information that's relevant to what you're doing, trying to solve that 25% problem that people have, that knowledge workers have. Let's walk through a simple example. In Nodlin, every Nodlin is associated with a folder, and a folder can contain many Nodlins, but a Nodlin can also be present in many folders. A folder is just an organisational principle. It's the same Nodlin if you put it in your working folder and your project folder, and you can share those with other users. Let's look at improved scalability. So here we see various types of node, one called an initiative, requirement, you've got features, and these are all connected and the update will propagate. So the requirement here, I can see I've got an effort for 60 days. And that's made up from two features here, both at 30 days effort. If I change one of those to 40 and save it, the requirement you can see has now been updated to 70. Now that's propagated through the whole network. So the initiative is updated. Now this initiative you can see is also present on another Nodlin. So that's another key organisational principle. A node can exist on many Nodlins, depending on your perspective. It's quite feature rich, the graph interface. You can add assignments to other people or just note them as an FYI. So they'll get a notification and they can open the Nodlin and check what you're doing. Just if you want to give notification to somebody. If I follow this through, for example, you can see up here the other Nodlins in which this node is present. If it's in purple, it means that this node is directly present in the other Nodlin. If it's in blue, it means that within this context there are other nodes that are present in other Nodlins. So it's likely to be relevant. Just makes it easier to find information. Also on this context bar on the right hand side here, you can see the folders in which this Nodlin is present. And these are all jumps, so you can click them as buttons and it will open up either the folder view or the other Nodlin. Let's follow this one through. So I open up enhanced Nodlin features and it's taken me directly to the same node but from another perspective. And you can see here that initiative is related to another initiative to enhance features of the software and an objective. So if management have formulated an objective hierarchy to manage KPIs for the business, you can follow that through. Now, this particular graph is probably best viewed as a tree. So let me view it as a tree top to bottom. And you can see here at the top, we've got an objective to increase revenue, which is connected to increased monthly active users and so on and so forth. So the graph view is not the only perspective that's available. If you select from the top, you can see the other ones available, like the graph, infographic, board, a Gantt chart. So you basically have a Nodlin of a set of data points and you decide how you want to view those. A good example of representing this information in a different way is my daily workspace. Here you can see I've got a list of bugs I've got to fix and a list of to-do items. And I'm viewing this as in the table view. Now you can save these views so that they're available to other users who are viewing this Nodlin. One of the other perspectives on this Nodlin I have, which is useful, is the bugs by severity, for example. The Kanban type view. So here you can see what critical bugs I've got and the high, medium, low. Now the reason I can formulate this view is because the form on the right hand side here is data itself. So when an agent handles a type, it's got the logic to manage a type, it can also provide a form which collates the data that that type requires, and that form is a JSON structure. So I can look at that JSON structure and pick out the optional fields and whether it's editable or not. And the advantage of that is it's also reactive in this view. So if I select one of these bugs and move it to critical, it will change and the data will change on the form. So it's reactive. In this example, we've got an agent that can help you construct a document. Might be an essay, a book, an argument in this case. They generally have a structure, it's a tree. A document is a graph, but there's an order. Nodlin can help you with that as well. So if we show this as a book, this is available in all Nodlin perspectives. You select your root node to act as the root node for the tree, and you can change the order of sections here. You can also export it, and so you can copy it as rich text and put it in a document, or just copy it as markdown. In this example, I've got a very bespoke case for communication. I remember being in an outage once where the size of the problem just kept growing and the number of teams in the chat just kept growing, and we lost the context. We didn't have time to all be on the same conversation. So how could we split that conversation out? The chat wasn't working. We split the chats. In this model, it's a very bespoke one for managing an incident. So there are various areas to investigate, and of those various investigations, there might be a number of impacts identified. Now, in this particular incident, we lost track of the impact because the person managing the outage needed to collate all these impacts from these different chats, so the context was lost. This is an ideal scenario where you can break out the conversation as a graph, and different teams can take their own perspective on the incident and start assigning tasks, incidents, and doing their own analysis. So here we've got three fundamental types: the incident, the investigation, and the impact. And you can see here that there are other Nodlins associated with this. In this case, this one here, where another team has taken on that investigation and identified their own impacts. And these are all, again, they're all live like the other Nodlins. This impact is open. If I was to resolve the impact, it would be highlighted straight away on the summary incident report at the top. So it enables you to maintain that central context. In this example as well, you can see we've got the team forming a cause-effect analysis. Now this is just another simple node type, and these ones can also be defined to utilize AI if required. In this case, we've got a database slowness, and we want to analyze what the potential causes for that are. Now let me just do one as an example. Let me just extend that analysis to identify additional causes for inefficient queries. So here you can see missing indexes would be the obvious one, and so on. So the AIs are not integral to Nodlin. It's the agents that provide the capabilities. So you can utilize your own AIs, your own internal ones, and different specialized AIs for different purposes. Now these need to be quite easy to construct because we're talking about communication. And from a tech perspective, agents in Nodlin can be defined as Python scripts or external agents that access firm internal systems that you can write in whatever language you like. The libraries currently are defined for Golang, but you can develop the scripts in Python within Nodlin itself. So because I'm a developer, I can view these scripts, and they generally follow the same pattern. You define the data payload, what kind of information you need to record for that node, and you can react to certain buttons that have been defined on the form. You can look at your related data and what to include. And in this particular case, we've got the AI query that we want to perform. That's performed by another agent. You just create an AI node, and when it's complete, it sends you a notification, and you can read that data structure back and create the related nodes. And this is what this script does. So this is the complete script. This is the code that creates the form, and this is all executes very quickly. Here, for example, we've got a tab called details, but if I was to just change this, I can do it because I'm in dev. I can save that, and you would see immediately here the tab here has changed to details too. Let me just change that back again. But it just shows you how flexible it is. These scripts can also be uploaded and shared and synced to GitHub, so you can share them with other groups. So the idea is to use the Nodlin interface itself to develop the script and test it out, and then you publish it for other groups to use. So it should be quite easy to formulate different standards of communication. What are the key points in communication that you're performing, say on chat, that you want to formalize, and then start using Nodlin in a structured way to manage your communication, as opposed to just using chat. Hopefully it reduces a lot of chat. And we haven't got time to go through too many more examples, but I'll take you through a few just to highlight the variety of different structured communication techniques that can be applied. Here we've got an agent that provides a library, and we've attached a document. So in Nodlin, you can attach files to nodes, and they're all stored in an S3 store, and they can be analyzed by any of the agents if you've got attached files. So here we have an AI reading the attached PDFs, processing the PDF, identifying the chunks, and you can ask questions of that library, which will answer it and provide the detail from the documents that it's got. So here I've got a question and an answer. Here's an example of De Bono's 6 thinking hats. Again, these are all integrated with AI. Here we've got one that can do investor analysis, and the AIs have come back with detail that I've presented. Here we've got one that just produces a mind map. So when you query the AIs, you can add additional levels and just keep expanding that out, or just supplement the detail on the node and then produce a document. You can help combine it with documents so that you can do analysis and research in mind maps and then link them to documents. Here we've got an example of the first principle analysis. And here we've implemented an agent that can manage and support the TOGAF application architecture documentation. And here's a simple example that can do workflow. So this is an internal agent type that can have general use across lots of different types of communication. So it's got tasks and options and milestones and everything else. And they're all reactive, and you can assign actions to workflow. People can complete them, and then they go on to the next step. Value pyramid, a Wikipedia example. So because Wikipedia has a knowledge graph and you can follow those relationships, you can extend and integrate with that and keep adding and expanding the nodes on the graph as you build out your research. Here's a SWOT analysis. And here's an evidence graph if you want to structure claims. What's the evidence? What's the rebuttal? What's the justification? And if you're at Google or other organisation that supports the OKRs, objectives and key results, you can utilise that framework in communication. Now, in this example, we've got an interesting case. In finance, you often have lots of different spreadsheets, and you want to take key details out of those to present and utilise in maybe other spreadsheets or just translate into other documents. Because files can be associated with nodes and an agent can read any file associated with a node, we've got a special agent type that can parse and process any named cells in an Excel spreadsheet. And here, for example, we've got our sales record, and we've associated an expression to that to read out the sales from Q3. So if I was to open the sales record, let's do that. Nodlin is integrated with OnlyOffice for doing the editing because it's online and web-based. And if I was to change the Q3 2025 sales record from 200,000 to say 300,000 and save it back, that would raise an event in the Minio store, which would then tell the agent that would then reread the file and process it. And here it's already done it. You can see it's 300,000, and that's impacted the target and the objective and so on. So if you're like the Chancellor and they're getting hundreds of spreadsheets from different groups, and the problem they've got is trying to understand what the key factors are across all those data sets they're getting, they can formalize the standard for how they're named, or people can associate and attach files to nodes that they're working on, and the Chancellor can review a summary of everything, as opposed to having to open and cut, paste and manage the data. It's managing that consistency. Nodlin is pretty quick at doing the calculations and processing expressions like Excel. It obviously has a lot more complications for dealing with complex data structures. And it has to manage loops, which Excel doesn't. Nodlin is expected to converge. So you have to allow loops. If you have a task related to, say, a subtask, they both care about each other. Task cares about its parent, whether it should still be in progress, and the parent needs to care about whether the subtask is complete. So when you're dealing with complex data types, you have to allow loops, but you have to manage that. Nodlin expects the solution to converge. Now, if you're an astute developer, you're probably wondering how all of this scales. So let's change one of the terms at the bottom of the stack. So the Nodlin charge per user, which you'd expect to change revenue forecast and everything else. So here I've got $10 a user. Let me change that to $12 a user. Now, you can see up here I've got the debug mode on, so I can see the trace. So I save that, and you can see there's little indicators of everything that changed, and the trace has appeared. So let me view that. So these are all the operations that happened after I made that update. So the first one would have been just updating that node. Then this is a checkpoint. So when you're developing in Nodlin, you can create your own checkpoint and execute operations. And if they're not dependent on each other, they can execute concurrently. And this is what happened here. There were 4 events that got executed on the back of that update that could all run concurrently. So if you see performance issues, you can add machines and capability, everything's stateless. So you should be able to cope with additional volumes on the platform. Now, there's another key that is critical to why Nodlin works. These events that get published do not have payloads. Now, if they don't have payloads, you can deduplicate the events. So if certain nodes get quite hot because of the large volume of updates converging on a particular node, you can introduce a lag. And by introducing a lag and dedupe, you can reduce or apply a small lag to the update itself and capture more events if the node is hot. Anyway, I can't go into more detail in this video, but the smarts in the algorithm are what manages that change and that deduplication And when there are concurrent traces happening, they can converge and another trace can take over, and so on and so forth. But that's the core engine of Nodlin underneath. In this particular case, because I'm the only user running this particular version, I can see that we deduplicated one operation, so not a lot. But you can see all the entities that were impacted, and by entity I mean node, and the status of all of those. You only see this if you're in development mode. But the key to Nodlin working is the stateless architecture and the fact that you can dedupe operations, and the busier the system gets, the delay on the lag that you can apply to operation execution can be applied. So it's that algorithm that basically makes it work at scale. But to summarise, Nodlin is quite a flexible tool. We've shown a number of examples in this video of the different types of structured communication that you can apply in your job in order to make communication more efficient. Nodlin does support a whole host of other examples that we haven't been through in this video, so you can take a look at those, a few of those online. Now, Nodlin is a self-hosted SaaS app. The agents will all be open sourced. You can use them as examples or use them as a starter for 10 to enhance and develop and configure them for your own organisational communication needs. And hopefully it will reduce email and chat. And also it will reduce the tax that we pay in order to keep multiple tools that are eventually consistent now. It'll keep the data between those tools consistent, and therefore save you a lot of time. There's also the benefit of more transparency. Multiple people in different teams can start understanding the context from other groups and not have to follow up with emails and meetings and chat, or maybe just have no idea what's going on. So it consolidates that flow, if you provide them with permissions to see it, of course.